All right, sup, how we be doing? Don't know what the hell I just said, but either way, we are going to be doing another problem, of course. Today it's called minimum difference element. Yeah, I don't know what else to say, so let's just get into it. Given an array of numbers sorted in ascending order, find the element in the array that has the minimum difference with the given key. Example 1, you have the input of an array with 4, 6, and 10. You want to find the key 7, or like the number with the closest, the minimum difference between the key 7. So then the output would be 6 because, that's the closest difference out of everything in the array. So I guess one way we can lead this first is by doing the potential solutions first. So we already know this one's 6 because we have that. Our answer for this will be 4 because 4 minus 4 is 0. For this one, for 12, the closest one is 10 because 12 minus 10 is 2, and so anything over here would obviously be further. 15 minus 12 would be 3, so 10 is the closest. And for this, it's 10 because 17 is the furthest from everything, and from 17 is out of the bounds of the array, and 10 is the closest, so 10 would be the answer. So we're going to have two if statements in a sense. So we have if key is less than array 0, then we just return array 0. Because there's no way we find anything else in the array that would be less than that because we're sorted in ascending order, right? And so same thing would be array length. Here we're gonna set left and right first, so we use 0 and length of array minus 1. And so here we'll just do left here. We'll just do left here because it's at the very beginning anyways. And then if the key is greater than the last item in the array, then we just return the last item in the array because there's nothing else you can find in the array that can potentially satisfy the solution that is not the very last element, right? So we're going to be doing a regular binary search. So mid is calculated with left plus right minus left floor division. And then so if array mid is equal to key, then we just return array mid, right? Else if array mid is less than key, then we have to do left is equal to mid plus 1, and then the else statement, which is just array mid is greater than key, we'll do right is equal to mid minus 1. And so this will take us to, the number that is the closest to key. And so with this, we have two numbers, right? We have left and right. So we want to check if array left minus key is less than array right minus key. Then we want to return array left, and then otherwise you'll just return array right. You don't need to do an else statement because if we return, this will never get called, and if it doesn't return here, then this will have to be called, right? And so that is the only way we can that's the only way we can essentially determine our number. And so yeah, I guess we can just mentally run through this first example first. So 7 is not less than the left value, which is 4, and then it's not greater than 10, right? So we have to go through our binary search. So our middle is 6 because 0 and 2 0 plus 1 would be 1, so it's this one. Find 1, it's not the key, it's less than the key, so we do left is mid plus 1, so left is now 10, and right is also 10. And then we will find out. Wait, okay. Okay, so now 10 left and right are now 2, right? So now the mid would be 2. We look at this, it's greater than key, so right is now to the left of it. So right is now 1 and left is still 2. So then we take the differences, right? So 10 minus 7 is 3, and it's not less than it's not less than 6 minus 7. So we return array right, which is 6. There we go. Okay, had quite a brain fart right there, but yeah, that's how we get the solution. So essentially, once we find like essentially the last number, we will have like this crossover where it's going to be between two numbers where we decide the value, right? So for this, the middle is 8. Since it's less than the key, we go left is here, right is here. And then the middle, I believe, so what is it? 0, 1, 2, 3. 3 and then 1 divided by 2. So it's going to be 3. So we look at 10, right? And then so since it's still less than, the left is going to be here. The right is also going to be here because we didn't move it. And then so since 15 is greater than it, we're going to have right here and left here. So it's always going to be around the two numbers that are around the value here, right? So that's why we can always do this condition check where it's array left and array right to see if we found our value. And so if we run our Python file, we get 6, 4, 10, 10. Yup. So with that being said, thank you for watching.